In this video, we're going to talk about key features of quadratics, specifically features that can be easily obtained using the form y equals a parentheses x minus h squared plus k, which we can refer to sometimes as vertex form or completed square form. First, let's look at graphs of our quadratics so that we can identify features from a graph. So we have the option with quadratics, our graphs are going to open up or they're going to open down. And that is going to be dependent on A, which we'll talk about shortly. But we can find a few things if we're looking at a graph. So these are our x-intercepts because this is where it crosses the x-axis. So this is an x-intercept and that is an x-intercept. We also have x-intercepts over here, so it doesn't matter if it opens up or down. Oftentimes you have x-intercepts. We could have a graph with no x-intercepts where it never crossed. And we also have y-intercepts, which is where it crosses my y-axis. And then we have a y-intercept over here. So just recognizing these features from a graph is good. And now we have our vertex. And this point right here is our vertex. And if you notice, since this graph opens up, that's the lowest point on my graph. So we're going to call that a minimum. And here I have a vertex. But if you notice, since my graph is opening down, that's the highest point on my graph. And so we're going to call that a maximum. One last key feature that I want to look at is at this point here, at our vertex, we actually have an imaginary line here that is called our axis of symmetry. And it cuts the graph right in half, so that if I folded it over that line, the right side would match the left side. And then we have one over here as well. So what that means for you is that this point must be the same distance from my axis of symmetry as this point. And so sometimes that helps you to graph if you needed to graph. Okay, let's look at some examples. So this is our form y equals a parentheses x minus h squared plus k. And from this, we can determine the vertex. So the vertex is always going to be h, comma, k. So it's going to be the number that I have here. Notice the sign change. If this one was negative, this one will be positive. And if this one was positive, this would be negative. And then I have k, and notice that those do not change. So whatever sign you see here is also going to be here. Understand that this minus sign is part of our formula here. And so if I have a minus sign in the formula and I have a positive here, I'm taking the positive out. But remember, putting a negative here would make a double negative and it would make it plus. So you're always going to flip the sign for your x coordinate of your vertex only. Once we know this vertex, we can actually get a lot of information from this vertex. And so our axis of symmetry, we write that as the equation of a vertical line. So that is always going to be x equals whatever the x value of our vertex was. And now the range, we have two options for the range. We're going to either have y is greater than or equal to, or y is less than or equal to. If a, this a right here, if a is greater than 0, if a is greater than 0, that means my graph is going to open up like this. So if a is positive. And you see that if a is positive, we have a minimum point there. And from that point, the rest of the points are above it. So our range would be y is greater than or equal to the k value, so the y value of my vertex. So if a is greater than 0, for our range, we'll have y is greater than or equal to. If a is less than 0, my graph will look like this. And so I will have a high point and all of the other points on my graph will be below it. And so for our range, we would say y is less than or equal to k. So notice from my vertex, I can get the axis of symmetry and I can get the range. I do have to look at A to determine if I'm going to use greater than or equal to or less than or equal to. A couple other things that we're sometimes asked is what is the maximum or minimum value? Now, the maximum or minimum value will always be K. Just, it'll be a maximum if A was less than 0. So that's a maximum there. And it will be a minimum if A was greater than 0. So you just got to think about that, or maybe sketch a graph. That helps sometime. The other way that they can word this, instead of saying max or min, they can say least or greatest value, and that's still going to be k. It's just max, they might use the word greatest instead, and min, they might use the word least, okay? And so these are the things we can identify from this. Now, we all know that a y-intercept is where my graph crosses the x-axis, and to find the y-intercept, I could plug 0 into x and solve for y. Okay, and we've done that with other types of equations as well. And then for the x-intercept, I can plug 0 into y and solve for x. Okay, and finally, the domain for quadratics. If you think about a quadratic like this, I'm going to just keep on going and get wider to the left, and I'm going to keep on going and get wider to the right. So there's really no x value that is a problem for me to plug in here. And so the domain is going to be all real numbers, and that's what that symbol means. Okay, let's look at this with a real example here. I have already written this in completed square form for you, and so all we need to do is identify the vertex. Remember, the vertex is going to be this value, but it's not going to be the -2, it's going to be positive. And then -4. This sign stays the same. Once we know this, we can answer all of the other questions. So we have x equals 2 as our axis of symmetry. And for our range now, we need to look at this here. This is a 3. That's greater than 0. It's positive, so my range is going to be y is greater than or equal to, but it's always going to be that y value, so -4. The max or minimum will be -4. Now, we need to determine if it's a max or a minimum. Now, remember, this is positive. So if this is positive, my graph is going to open up. So I will have a minimum value. The domain is always going to be all real numbers. Now, using this max min, we can talk about the x value where it occurs. So sometimes they want to know, what is the max or min? That's -4. But then what's the x value where it occurs? Well, that's just going to be the x value of my vertex. It occurs, in this case, at x equals 2. So now we can sketch a rough sketch of this graph. So we have 2, -4. So that's going to be my vertex. Okay, and I know that it's going to open up. I know that I'm going to have an axis of symmetry right down the middle here. So maybe I want to find one other value or one other point, and you can do that in a lot of different ways. You can just plug in a point into x and see what happens, or we can plug in 0 into x and figure out our y-intercept. And so if we find our y-intercept for this graph by plugging in 0 to x, you're actually going to get 8 out. Well, in this case, that's a little too high, so we would have some idea. So we can plug in 1. What happens if we plug in 1 to our graph? I get 1 minus 2, which is -1 squared is 1, times 3 is 3, minus 4 is -1. So once we know that we have a point there, remember that it's going to be equidistant from the axis of symmetry, so I have another point here. Now, it's really hard for me to draw nice graphs up here, but roughly, I'm going to have a parabola that goes through that. Now, that's not really pretty. Hopefully yours looks better. But that's the idea, and we can sketch a rough graph, okay? We could also have found x-intercepts if we wanted to, but since we're just going to sketch a graph, this gives me a good idea of what it looks like. I can always find additional points if I need to. Okay, let's look at this one. Now, this one is not in completed square form. So oftentimes, if we have this in standard form, we're going to want to write it in completed square form. Guys, I'm going to assume, because we've talked about it, it's a skill that you need to know, that you know how to write this in completed square form. And if you don't, then you need to go back and you need to watch the video on completed square form. Okay? So when we write this one in completed square form, you are going to get y equals -1, parentheses, x minus 2 squared minus 2. And from this, we can find the vertex, which is going to be +2. Remember, that sign changes, but this sign stays the same. And then our axis of symmetry is x equals this value, 2. The range is going to be y, and we're going to have this y value, -2, but we need to decide, do we put greater than or equal to or less than or equal to? Well, we need to look at this right here. This is negative, this is negative here. So because that's negative, I know that my graph, I know that my graph is going to open down. And so I'm going to say y is less than or equal to, okay, because a is negative. So that means I'm going to have a maximum value. And my maximum value, though, is just going to be my y value of my vertex. The x value where it occurs is the x value of my vertex, which is 2. And the domain for all quadratics is all real number, unless we've restricted it for some reason. Okay, why don't you take a minute and pause the video and write this in completed square form and then answer these questions. Okay, hopefully when you wrote this in completed square form, you got y equals 2, parentheses, x plus 2 squared plus 4. And so our vertex, remember, is going to be opposite sign, -2, and then same sign, 4. Axis of symmetry will be x equals -2. The range is going to be y, and we're going to use our y value of 4, but we have to decide, am I going to use greater than or equal to or less than or equal to? This a right here, this 2, is positive, so we're going to have a graph that opens up, which means I'm going to have a minimum value, or a least value in this case. It also means that my range is going to be greater than or equal to 4. I have a least value of 4, and the x value where it occurs is going to be -2. That's the x value of my vertex. Okay, so the least value is going to be the y value of the vertex all of the time, and the x value where it occurs is just the x value of the vertex. And the domain is all real numbers. Okay, we're going to look at 2 more, so why don't you pause the video and take a minute and try to write this one in completed square and then answer those questions. Okay, when we write this one in completed square form or vertex form, we get y equals -1, parentheses, x minus 3 squared, and actually we have plus 0. You would have gotten plus 0 out here, which you can write if you want to, but I don't need to. So when you see something like this, understand that the vertex is going to be the opposite sign here, +3, and since I don't have a value out here, it's going to be 0. That means the axis of symmetry is going to be x equals 3. The range is going to be y, and we're going to use 0, which is our y value, and we have to ask ourselves, does the graph open up or down? A is negative, it opens down, so I'm going to use less than or equal to. And in this case, since it opens down, we have a maximum value, so we have a greatest value of 0. It's always the y value. And then the x value where it occurs is 3, and the domain again is all real numbers for quadratics unless we've restricted the domain. Okay, take a minute and try this one. Okay, this one's a little tricky because guess what? It's actually already in completed square form. I could write it like this just to show you. I could have a 1 here, and I would have x plus 0 squared minus 2. And so we don't actually have to have this 0 there. So when you see an x squared here and you don't have another x term, you have a constant here, then it's actually already in completed square form. And this looks much nicer than this. So if you recognize that, we know the vertex is going to be 0 because I don't have parentheses here, and then -2. That means the axis of symmetry is x equals 0. The range is y, and I'm going to use the y value of -2. Since this a here is positive, it's going to be greater than or equal to. Again, since a is positive, it opens up, which means I'm going to have a minimum value of my vertex. The minimum value is going to be -2, which is the y value. And the x value where it occurs is 0. And the domain is all real numbers. Okay, we'll discuss this more in class, but I hope that helped.